Hello, welcome to Astronomy Toronto. My name is Randy Attwood. This is the third in a series of programs on astronomy where we discuss current topics in astronomy and also talk about current activities of both amateur and professional astronomers in Toronto. Today we're going to be looking at eclipses and see slideshows on two recent expeditions that the Toronto Centre members have taken during the last 2 years to see two solar eclipses. With us again today is Ian McGregor from the McLaughlin Planetarium, who is also the president of the RASC and was on both the expeditions. Hello, Ian. Thanks for coming
Hi,
by.
Randy.
What is an eclipse, Ian?
Eclipse is a very spectacular event when you're able to observe it. There are basically two different kinds of eclipses that can occur. We have what we call solar eclipses, and we have lunar eclipses. The first, both of them are concerned when you have shadows. In particular, the lunar eclipse. Lunar eclipse occurs when the moon, orbiting around the Earth, passes through the Earth's shadow. Now, it takes the moon about 30 days to go around the Earth once. However, that does not mean that we have a lunar eclipse every month. Instead, we have perhaps maybe one or two lunar eclipses that occur each year, visible over some part of the Earth. Lunar eclipse is occurring when the moon goes around the Earth. It passes through the Earth's shadow, and for a whole hemisphere of the Earth, it is possible to observe the moon. First of all, it's a full moon that we would be seeing in the sky, and then we have a gradual wave of darkness spread across the moon, which is the Earth's shadow. This is a lunar eclipse. They're quite interesting things to observe. We've not had a lunar eclipse visible from Toronto for several years now, but there's one coming up in about 2 years' time. The other kind of eclipse that we have are solar eclipses. Solar eclipses occur when the moon passes between the Earth and the Sun, and the moon shadow falls onto the Earth. This is, again, not a particularly common event, but each year we may have some kind of combination of maybe up to total 5 solar or lunar eclipses of various types.
I think we have a picture of what the diagram of the Sun and the Moon and the Earth in this configuration. We can take a look at that, and maybe you can tell us a bit more about what the circumstances of an eclipse are. Here we have the Sun on your left and the Moon in the middle and a bit of the Earth on the right.
This is a configuration for a total eclipse of the Sun. We have the Sun's radiation coming from the left, and we can see the moon's shadow falling onto the Earth. The central cone of this moon shadow falling onto the Earth might cover maybe at one particular instant, maybe an area of the Earth perhaps maybe 300 kilometers in diameter. The outer cone of the moon shadow might cover perhaps, a whole hemisphere of the Earth. We might be able to actually observe this event taking place. These two expeditions that the Toronto Centre has been on in the past 2 years, 79 and 80, were to witness total eclipses of the Sun.
Why are total eclipses worth going to see?
Well, they are by far the most spectacular events that we can see in nature. The first recorded instance of a total eclipse of the Sun goes back somewhere around 2100 BC. And ever since that time, people have been fascinated by it, whether they're ancient sun watchers or even modern day people. I know from our own expedition, as you will readily agree, we had lots of people who went really crazy at this event taking place.
Mm-hmm. As much as you read about it and know what's going to happen, there's just no way you can be prepared for what happens.
There just isn't any way you can be prepared if you happen to be in the path of totality. This is where the central shadow of the moon falls onto the Earth. It is an overwhelming event. We probably should mention that there are 3 different kinds of solar eclipses. We have partial eclipses of the Sun that occur when the moon goes between the Earth and the Sun, but it doesn't completely cover the Sun. And only a small chunk is sort of seems to be taken out. That's a partial eclipse. We can also have an annular eclipse, which is when the moon is at its greatest distance from the Earth, and its angular size is not that great, and it does not completely cover the moon. Can cover the Sun, rather. One of the interesting coincidences in nature at our particular time in the history of our planet is that although the Sun is about 400 times larger than the moon, it is also about 400 times further away. And the net result is that when we observe the Sun or the Moon in the sky, they have roughly the same apparent diameter, about half a degree. And at various times when their motions sort of set up the proper conditions, the moon can just cover the Sun and then we can witness a total eclipse of the sun.
And of course, the total phase only lasts from a few seconds to not greater than 7 minutes.
Not greater than 7 minutes. 7 minutes is the maximum amount that you can get at any one time.
One of these total eclipses that occurred was in Manitoba, especially on February 26, 1979, and 106 members of the Toronto Centre flew out there just for the day, just to fly in, see the eclipse, and be back for dinner. Ian and I were on this expedition, and we put together a few slides that will show you what it looked like, and maybe you get an idea of how gorgeous these kind of things are, and we'll talk about exactly what it looked like. Here is a map of North America, and you can see just a path, an oval path going through United States and then Canada. That's the path of totality.
That's path totality. In this case, we can see that all of North America is in the range of the sort of a partial eclipse of the sun. However, the path of totality is only a narrow band, about 300 kilometers wide. The moon shadow fell onto the Earth in the Pacific Ocean and swept across the United States into Manitoba, across northwestern Ontario, and the eclipse ended at sunset in Greenland. So this event was a very spectacular event. There were probably tens of thousands of people in North America that actually observed this incredible event. And we went to Manitoba, Gimli, Manitoba, in order to observe this particular eclipse.
The area outside the path, what would they see?
They would just observe a partial eclipse. In Toronto, we saw about 74% of the sun's face covered by the moon. Here are our planes. We chartered 2 aircraft, and they flew us to the airfield at Gimli, Manitoba. The members are setting up their telescopes, and temperatures around 15 degrees below zero. We have about an hour and a half before totality actually occurs, and we have some more of the members setting up their instruments. It's a very large expedition, and we occupied a good portion of the airfield as we were waiting to get set up.
It's rather cold, too.
Oh, very definitely. And here we are. This is just shortly after first contact. We're observing the sun through a filter, and that's why the sun appears to be bluish in color. If you look at about the 2 o'clock position, we can start to see the moon starting to cross the sun's face, and we're going through the partial phases now. In this picture, we can see several of the telescopes. There's one on the right and 2 over on the left that have got filters in front of them. Again, you never look at the sun with your naked eye. You have to observe the sun using some kind of a filter or some kind of special protection.
Well, why does it look blue then?
Well, this is because of the color of the filter. Some filters give it a very orange sun, others give a very blue sun. This particular picture is showing sort of a kind of a blue sun that we're looking at. That filter is protecting it.
There's another way to view the eclipse.
There's another way as well. This is
the safest way,
This
really.
is the safest way, exactly. This is by projection methods. Here we have a telescope, could be a pair of binoculars. Light enters the telescope, it goes down the tube, and then it's projected onto a piece of paper or cardboard, and as we see in this particular picture, you can see the partial eclipse taking place. Using this method, we're looking at, here's a person using a pair of binoculars. Using this method, we're not actually looking at the sun with your eye. You are just seeing an image of the sun, and that bright intensity which could damage your eyes is all out of the way.
Here we are getting quite close now.
Oh, it's really going along now. Look at this. We're about 80%, 85%.
It's still quite bright out. It's nearly total, but it's still daylight out.
That's right. This eclipse is taking place during the daytime, but we got and so much of the sun's face that it still appears daylight outside. It's not until about the last little while, the last few minutes.
It's quite dark now.
Oh, here we go. We've now gone into the total phases. It's very, very dark now. We're just shortly before totality starts. We have a sort of twilight period. Shadows get very, very strange. All the colors get very distorted.
It's the last bit of the sun remaining.
It's the last bit of the sun remaining. There we have our...
This is just the moment of totality begins, where you see the diamond ring. What is the diamond ring? I've heard of that many
Diamond
times.
ring is a very spectacular event. It's just the last little bit of the sun passing through the very nice diamond ring, passing through the mountains on the edge of the moon. And as we look at the sun in the sky, it appears like we have this beautiful diamond ring effect. Spectacular sight. It's just overwhelming. It really gets to your emotions.
This shows you the edge of the shadow just moving from right to left, and you see at the bottom left-hand corner. And there is the last bit of sunlight disappearing between a lunar valley. Now these slides are good, but you really can't get an idea of what's happening unless you see it. And we have a special film for you. So here is what it looks like. here's totality, and there's the silvery corona coming around the moon there, the black moon, which you can't see unless you see a total eclipse.
The moon almost looks like a black hole, more or less. We already just sort of a black hole in the sky. And we're starting to see the corona around the sun. The corona is the sun's outer atmosphere. Hydrogen gas heated to a temperature about 1 million degrees, and the corona is only visible around the time of totality.
And of course, the person working the projector is just opening the aperture. Now, what you can see at this point is a lot of the middle atmosphere of the sun, called the chromosphere, which is the hydrogen gases bubbling and frothing into prominences and flares. And here's a picture where you can see there was a huge, gorgeous pink prominence at the 7 o'clock position, and another one up at the 10 o'clock position.
Chromosphere is very spectacular. It's the chromosphere, or the color sphere of the sun. And the red color is coming from the hydrogen gas, heated to quite a high temperature.
Here's another picture where you can just see a few of the prominences. It's a very short exposure, and it's kind of dark, but this shows that with photography, it's difficult to capture everything that's going on at the same time with an eclipse, as many people who've taken pictures at an eclipse know. If you're watching an eclipse, you can see all of the corona and all the prominences at the same time. But with a camera, you have to take various exposures from a very fast thousandth of a second down to several seconds to capture everything you see with your eye.
Yeah, you're only getting one or the other, but you're not getting the whole works at the same time. That's where it shows how powerful a tool the naked eye is.
It's unfortunate that we can't, take everyone to see an eclipse, but this is the next best thing. But you remember that you have to see one to actually encompass all of the sensations.
Which it might be worthwhile to point out at this time that with the sun's face completely covered by the moon, it is safe to look at the sun at this particular time.
Right.
You do not need any protection, any filters. You can just look at the spectacular sight that's occurring in the sky.
That's right.
For many of us who were observing it, we were just sort of awestruck by it. You're all set to take photographs and do any observations, and suddenly this magnificent event is taking place. You just sort of, well, I stood there for about the first half of this eclipse. The duration was about a little less than 3 minutes. And about the first half of it, I sort of stood there.
Right.
This is incredible. Look what's happening.
The amazing thing is, here we are. We went there to see it. We knew exactly what was going to happen, but we just went absolutely crazy when it happened. And I couldn't help but think, what about people hundreds and thousands of years ago who looked up and saw these things and didn't know what they were?
Oh, they must have been very frightened. I wouldn't blame people for getting out with their spears and shooting arrows into the sky in order to try and scare away the dragon or whatever it happens to be that seems to be eating the sun. And even today, with our modern ideas and our 20th century people, we can still be very awestruck by this enormous event in nature.
You can see this glow around the horizon. This went all the way around, 360 degrees around the horizon, this salmon glow. This is because the shadow let in, there was some light coming in where the eclipse wasn't total, and then we would see this glow around the horizon. Here's another gorgeous picture of the eclipse.
Oh, that corona is really standing out very nicely. You can see lots of detail, all kinds of streamers in the corona. Again, that corona is a gas of temperature about 1 million degrees. It's only visible for a few, just at times of totality. In fact, in the last 100 years, the corona has only been observed for periods of about 4 hours, grand total. That's from all the eclipses that have occurred in past years.
You can see much fine detail and wisps in it, and here's a closer
There's
picture
a nice
where you
close-up.
can begin to see a lot of fine detail. There's a strange marking at the top there. It looks like an S. What would that be caused from?
Well, this is actually a structure that we'd associate with the corona and some of the streamers that are in it. And it's worthwhile to mention that the corona for each eclipse is different, and sometimes this corona is very spherical. At other times, it's kind of very elongated. Here we're seeing a lot of the outer corona visible there, and we're going right in quite close.
It looks like the moon the moon's always moving during this, but it's because it's larger than the sun that it covers the sun up. And now you can see that the prominences on the left are are disappearing.
Just starting, that one, particularly that one at 7 o'clock.
And we saw the one on the right coming up. It looks like totality will be over in just a matter of seconds.
Spectacular event. It was just incredible kind of capturing this, and everyone in the last few minutes was just trying to, remember everything that they could see. This tremendous event.
It's quite a sight. It gives you the impression like you really don't know anything's happening until maybe 2 minutes before totality. It's as if the sky flip-flops, as if daylight, sort of disappears for a minute, nighttime comes, and then at the end...
Start to see some stars, perhaps some planets start to become visible.
Here's the diamond ring on the film.
There's a nice diamond ring coming on.
And suddenly you see it becomes daylight again, and there we are, a jubilant group of astronomers.
Success.
Didn't get clouded out.
We had done it.
Didn't get blinded.
An incredible event that we're all going to remember. A lot of us, of course, got eclipse fever from that as well.
Which brings us to our next slides, which is the eclipse in Kenya. Now, it was quite a trip to Kenya, a bit more expensive than going to Manitoba, but this eclipse was also a bit longer.
That's right. It was worthwhile, I think. We had the eclipse to Gimli, Manitoba. It was kind of a day trip. So we left in the morning, came home in the late afternoon. Going to Africa, though, was quite another experience, but it was an eclipse that was lasting almost twice as long.
It was very similar from the Gimli eclipse, but also very different. And we have a bit of a change of pace here. We're going to show you what the eclipse looked like, but also play a bit of the sounds that were made by us astronomers during the eclipse, so maybe you get an idea that you're actually there. So we'll take a look at that slide now. Okay, the crescent is getting smaller now. Crescent is shortening. Okay, at a 20th. At a 20th. Oh, it's going to be gorgeous. 20. This will be... I'll take one more shot after this. Shadow bands? 2 minutes! Shadow band. Here it comes. It's getting very small now. 21, 22. Coming up 1 minute. Last partial. Last partial. Filter. Shadow band. Yeah. Oh yeah. I see the corona. There's the corona.
Oh, look at the shadow band.
Oh, shadow band, incredible. Beautiful. We got it. Oh, providences galore. Film's off. Not very bright. Not very bright. Okay. Okay, we're starting at 1,000. 500. 250. Mercury. We see Mercury. Oh, this is so great. 30th. 8. Okay, we're gonna straighten it out. Get it centered. Oh, beautifully centered. Quarter. Half. 1. Oh, birds just went in
Yeah,
front.
birds right across.
Look at this. It's not very dark, is it? Time. No, no way. Can't see all there.
82 seconds.
Oh, look at the prominences at the top.
Yeah, 10, 11 o'clock.
30 seconds.
Oh, the prominences at the 2 o'clock with the sunset, the sunspot scene. Okay, we're going to 125th now. Start the camera.
20 seconds.
Take a look. Oh, lovely! Oh, the colors! Look at it go! Oh, the slowest diamond ring! You've done it!
That beats a rhino all the time.
Oh, incredible!
Oh.
Wow, it was really great to see that again.
Just fantastic seeing that. It's just an incredible sight. You know, one eclipse we've already seen in Manitoba in 1979, then seeing those pictures from Kenya.
But there was a big difference there. In 79, the prominence were very evident, but they weren't as evident in Africa.
No, that one at 7 o'clock in Manitoba. It was very noticeable, but in the 1980, it was really the corona, the streamers and such had lots of detail.
When is the next eclipse, total eclipse of the sun, Ian?
The next total eclipse of the sun is taking place in July of 1981. For people who want to go and see that, it's going to be taking place in eastern Asia, and the moon's shadow is going to sweep into Siberia. The best place to go is Siberia, and there are several expeditions that are planning to go there. No Toronto Centre expedition.
Well, how long will totality be there?
Totality there, I believe, is somewhere between 1 and 2 minutes.
So it's not very long.
Not a very long one to go to.
There have been several partial eclipses in Canada, and here seen in the Toronto area. The one in 1979, you could see it partial, but I believe it was cloudy. When was the last total eclipse you could see here in Toronto?
Well, perhaps some of our listeners may have even witnessed seen part of the last eclipse. The last eclipse was in January of 1925, and the path of totality passed just south of the city of Toronto.
So when will the next one be that we will be able to see from Toronto?
Well, to be able to see one from Toronto, Toronto is not in the path of totality for probably many hundreds of years. However, the next good one that's passing relatively close to us is in the year 2024. So that's the date to kind of circle on your calendar. There are other eclipses that are coming along. There is one in 1991 that a lot of Toronto Centre members are planning to go to. There's another one in 2017, which is another Canadian eclipse. It'll be a long time before we have another Canadian eclipse.
What we're working on right now, of course, is to go to Indonesia in 1983.
That should be very exciting.
Because it'll be a 5-minute eclipse, which is rather long, and then the one in 1991 will be just about as long as total eclipses can be, where the moon appears the largest and the sun appears the smallest, and it'll be 7 minutes of nighttime in the middle of the day. Should be very exciting.
Total eclipse of the sun only occurs about maybe every 1 year and a half or something like that, and this is a spectacular event in order to be able to catch one.
Well, I think both Ian and I hope that you out there will get a chance to see a total eclipse at least once in your lifetime, if not many more. I think we're going to be following eclipses for the rest of our lives.
Eclipse fever.
Thanks very much for coming by again, Ian.
Thanks, Randy.
My guest today has been Ian McGregor from the McLaughlin Planetarium. My name is Randy Attwood, and for the Toronto Centre of the Royal Astronomical Society, we'd like to thank you for watching these shows, Astronomy Toronto, and we hope to be coming back to show you a few more shows later on, maybe this year. So That's all for now. Thanks for watching.